This is what I love to see. This is what I love to see. Remember this, the most professional C++ project ever, this Snake game, which had Jira and like all of this project management along with 80 something commits it was back then. So we did a code review over this code. And of course the project management aspect was completely just blown out of proportion, which may have been a bonus if you're looking for a job in the industry. Some people definitely seem to think that it would help appeal to some hiring managers, but the code itself, well, there were some issues with the code. It just didn't really quite feel like it matched the level of, well, quite frankly, this. Now, I actually asked you guys to make some suggestions on Discord inside the Code Review series channel, and you did. We're gonna be going through some of them today because there was quite a lot of discussion here, which is great. But before we get into that, our boy here has actually already made some improvements to this project. One of the big complaints that I had was basically the whole application flow. I mean, there were some ridiculous things like having a main application while loop, but then also each state had its own application loop. Anyway, I definitely recommend you watch that video. I'll leave it linked up there. So imagine how happy I was when I saw that 5 and 4 days ago, we have a game state class now. See, this is great. I love it when I give suggestions and feedback and people actually implement it and improve their code. And now with this whole Discord channel thing and of course the YouTube comments, we're able to do that more as a community, which is awesome. So today I want to take a look at two things. First of all, this game state class. So what this guy's actually done to improve the application flow and the whole lack of state machine thing, which I'm guessing this solves. But then I also want to go through the feedback that you guys have left on Discord, of course. So we're going to do both of those things. Now I'm hoping that this game state class situation, which we are going to have more of a look at. Oh, look at this. He's even made improvements such as adding STD to these things. So probably removing the using namespace STD, which some of you pointed out on Discord was not the right thing to do. And in fact, I even made a video years ago talking about that. Lots of various improvements, as well as, look at this, an entire game state system that we're going to dive into. This is great because it's hopefully going to elevate this project from just being a showcase of project management and actually make it have some really well architected code, which is going to help immensely. You know, honestly, you might as well go all the way with this project and actually make a website showcasing it. But I don't want to waste time making a website. I'm not a web dev. I don't care about that stuff. Let me stop you right there. I have the perfect thing for you. Something that will just make the website for you. And that is Hosting Horizons, the sponsor of this video. Hosting Horizons is your all-in-one AI partner to create websites from start to finish. Just describe your idea and Horizons instantly builds a working, mobile-friendly website or web app. Backed by hosting infrastructure, you can set up hosting, a domain, and email with a few clicks, ready to launch and grow from day one. And with a 7-day free trial plus 30-day money-back guarantee, there's no reason not to try it. Horizons uses a mix of the most reliable LLMs, which works quite well. Let's give it a go and see if we can quickly make a website for this Snake project. Okay, so the first thing we have to do is describe what we want. So let's create a portfolio website for, I wonder if we can just grab this README file and just paste that in for this Snake game. That contains a lot of stuff that we obviously don't care about, but you know what? Let's just run with this and see if it's really that easy. Okay, here we go. Oh, check this out. There's even a little snake logo that's like hovering. That's kind of nice. What do we have over here? WASD controls, moving food challenge, 3 unique levels, rarely rendering, unit testing, game patterns. It even generated some images. That's hilarious. Technical excellence built with modern C++ practices. It's got all the catch to unit testing, Doxygen documentation, all this crazy stuff. A little project structure. This actually looks really nice as well, the way it's presented, might I add. I mean, of course, you know, I pasted in the whole README, which included this stuff, which you probably wouldn't include in a portfolio website. But the fact that it's taken that and made it so aesthetically pleasing, I think is pretty impressive. And then there's get started here at the bottom, run the game. I really like this glowing green download game button. That's really cool. And then we've also got some instructions on how to run the tests. Now, obviously these images are something that we'd like to replace. So we can actually, we've got like this GIF here, game capture GIF. I wonder if we can just give it that and be like, replace the first image under the level 1 classic heading with this GIF. Let's see if it can do that. Okay, that was pretty quick. Let's scroll down and there it is. There's our GIF that's playing over here, which is pretty awesome. We can also click this edit text button if we want to go through any of this and change it, and also browse the code in case you want to add some custom stuff that you don't want to do through the prompting, which I think is good. It's always good to have that level of control, of course. One more thing I might ask it to do is change the background color to be a nice gradient green, like the colors in the GIF. Let's see if it can change that background color. All right, there we go. That was really quick as well. Okay, assuming I'm happy with this, I can go ahead and publish it. Let's have a look at the site. And there you go. I mean, look, that took like a couple minutes. It's crazy what the world is coming to. And check it out, mobile friendly. So go ahead and launch the idea you've been sitting on today with Hosting Horizons. Go to hosting.com/Cherno10, link will be in the description below, and use code Cherno10 to get 10% off yearly plans, which include free hosting and a free domain. Huge thank you to Hosting Horizons for sponsoring this video. Okay, so getting back to the diff. He's added some comments over here to make these smart pointers, which I'm guessing is good. I mean, I don't know exactly what level food stack used to contain, but either way, like raw pointers, I generally would advise pretty much everyone to almost never use raw pointers or like the new and delete keywords, unless you're specifically dealing with like low-level memory management things, whether that be for a data structure or like a memory allocator. Obviously for stuff like that, you're probably going to need to use that style of programming, shall we say. But when it comes to higher level programming, so like all of this is gameplay related, right? These are not low-level systems. Like we're creating frogs and mice and I don't know, adding them to the level food stack. Like this should not be using the new keywords. So making this stuff smart is very important. Now they actually could already be smart pointers because both the shared pointer and unique pointer classes do actually have constructors that take in pointers and then they kind of make them smart, I guess, by taking over ownership and management of that particular memory. So to be fair, just by looking at this code, level food stack could already be a collection of smart pointers, we're not sure. But either way, there is std make unique and std make shared for a reason. And the latter, std make shared, is actually really important to use because it does something different than when you actually use the new keyword constructor of std shared pointer. And that is to do with the way that it stores the reference count. It will store it alongside the object and it will allocate everything at once, versus this, in which it has to basically have an external block elsewhere in memory that will contain the actual reference count, and then it'll have to allocate both this and the reference count, and things get messy. I might make a video about it. Anyway, moving on, yeah, removing std, changing this as well to smart is good. And then we have the game state. Now this is just what looks like a little skeleton setup. I'm not even sure why you would commit this per se. I would just actually do it in the commit that includes the game state, but whatever. Here's the create game state class commit, which includes a lot more actual implementation. So on initialize level, we seem to reset some pointers. See, I try and avoid this as much as possible. Like you can't always avoid this. So if we come over here into Visual Studio, you can see that inside the game class over here, we have board render, snake render, and food render, which are all unique pointers. By calling reset, we are basically deleting that memory. We're freeing that memory and resetting the unique pointer to just point to null. Now, in my opinion, this is annoying, because what we have essentially done is removed the usefulness of this even being a unique pointer. Like, yes, there's still obviously the benefit of we don't actually have to delete it when the class gets destroyed, because since this is a unique pointer wrapping a memory allocation, once the unique pointer dies, which will happen when this class dies, we don't have to free any of this underlying memory, which is great. However, we shouldn't really have to do this, because when you come over here and you actually, well, call make unique again, which is missing that std. I guess he didn't remove using namespace std. Where is that even defined? Did I see that last time? When initialize level 1 happens, it's going to recreate all of these objects, which obviously means that the old one will get deleted, because that's how unique pointers work. The only reason to explicitly reset them is if you specifically need the memory to be freed over here. But again, that doesn't really quite make sense because we're in the same scope, we're in the same function. We're just going here and recreating the objects anyway, which kind of means that you might as well have just kept new and delete, because what you're doing here is basically just this. It's just formatted slightly differently. So what's the point? Anyway, the key takeaway from this is understand how smart pointers work, understand how unique pointers in this case work and why we use them. Because going through and resetting everything manually, even though you're going to be recreating it anyway, and that's going to achieve the same thing, kind of shows that maybe you don't quite understand how they work. Also, just a little side note, we have a .get here, which obviously gets the raw pointer from this smart pointer, because render snake must have a constructor that takes in a raw snake. So this is actually somewhat a tough one, because render snake is a separate class that handles the rendering of the actual snake object. So what it needs to do is obviously have a reference or have some kind of, I don't mean literally a reference. I just mean it has to have access, I guess, to the snake object that it's trying to render because it needs to render it. But then ultimately it doesn't quite have to own it, because the way this is set up is that this is only active. This render snake thing that is rendering the snake is only active as long as the actual snake itself is active. Now, in reality, this is kind of a dangerous design though, because who knows what render snake exactly is going to do if it actually has the right to just take the snake and always draw it. This is where we begin to perhaps run into some limitations of unique pointers. And I don't mean like literally limitations of the way that the class is written, but more the semantics and more like the architecture that you might expect when you come across them. Namely, the fact that they're more or less fine if you just use them within this class. So if we have a bunch of unique pointers and they're all used within this game class, that's no problem at all. But as soon as we start to, well, share them, you might be able to see where this is going. You might want like a shared pointer. Now, an important distinction is sharing them means that I am basically giving this object this raw pointer to this class specifically, because the way that this is happening is more or less a handover. The main problem with this is that the operations that render snake will actually do on the player snake pointer are kind of deferred. They're not immediate. They happen later because we're just giving render snake this pointer, and then we're saying later on, just in another function, later in the application, it's going to go ahead and actually draw. If instead we had passed in this player snake pointer like into here, for example, and you don't need to make it a raw pointer in this case. Instead, we would just have the draw function take in the unique pointer by const reference like this. The semantics that go along with something like this are very, very different, because in this moment, we're giving it access to our unique pointer as if this function was just implemented within this scope, if that makes sense. We're just kind of extending that unique pointer into another scope, but we're not handing it over or giving the class control of it outside of any of these scopes, because that's where the danger lies. So if you write the code this way, that's totally fine. But if you instead kind of hand over this raw pointer that who knows if that's valid or not. One example in which this actually would be a problem, even though it is kind of increasing the complexity of the architecture of this application, would be if we had like a render thread. If we had a separate thread actually doing the rendering, the way that that works usually is the render thread is actually a frame behind your main game thread. And so the game thread might be executing this code over here that's actually deleting that player snake object, but your render thread's still trying to actually render the snake for the frame that it's still rendering, if that makes sense. Now, obviously that's not what's going on here because there's just one thread. But that's an example of why this design falls apart, especially if you kind of hand over ownership like this in a not a very good way. So in that case, what you would do instead is this player snake object would either be a shared pointer, because then obviously the render thread could just have its own ownership of that object. And since it's reference counted, whoever finishes with that object last, that's when it gets deleted. Or in the other case, you would also make this a shared pointer, but instead of providing render snake with a strong reference of the object, you could give it a weak reference. I have a video all about weak references linked up there. That's not really something you would do for the whole render thread situation, even though I guess you could. But in that case, what would happen is instead of checking for whether or not snake is null pointer, which is meaningless since this snake will actually never be null pointer unless it's explicitly set that way. Instead of that, you would simply check the weak pointer to see if it is valid, and if so, you would proceed to render, otherwise you wouldn't. That's the safe and more robust way of setting up the architecture for this whole, how do I get an object from this class into another class and also hand over ownership kind of to it so it can do whatever it wants later. In C++, you really have to think about that stuff, even though in languages like C# and Java, you don't. The reason why is because C++ actually lets you decide exactly what you want to do with this, whereas in those other managed languages, basically everything is kind of like a reference counted object. It's kind of like a shared pointer, except it's garbage collected, so it's a little bit different. But the closest way to look at it is that everything you make, every object, specifically a class in C#, is just a shared pointer. So then when you go into C++ and you start making unique pointers or you start making raw pointers, then that's where things differ. Ratstail91 had a bunch of stuff to say over here in the Code Review Series channel. One of the criticisms was that the way that the actual levels were stored were static vectors embedded into the code instead of external text files like this. Now, if we have a look at what he's talking about, it's this. It's over here how we have a vector of bools that draws out our map, our level, what it actually looks like. So over here, you can see that we have a bunch bunch of zeros, which are presumably blank spaces, meaning tiles that both the food and snake can actually go on. And then ones are walls, as you would expect. So you can see we have like a structure over here. There's something over here that we can't pass by. Obviously, the whole border is also ones as well. Now, to be honest, I don't actually have a problem with this. I think that perhaps creating external text files might be a little bit overkill. I mean, again, I think that considering this whole project is overkill, obviously, why not just do that? Why not just do that so that you can show that you know how assets and level files work and how to read them, and like that's useful to show to someone who might be looking to hire you, or if you're just making this project as a showcase, which it seems like you are. So yes, on that note, I think that external files probably a good idea, but you can also just refine this a little bit. I think the ones and zeros idea is fine, but why is it a vector of vectors? Why not just have a single dimensional vector? Because you absolutely don't need this, or even just having a single dimensional array. Honestly, that's the best way to do this. So instead, you could just have one array. I think it's like 12 by 12. So you could just do 12 by 12, and then you would trim out all of these. We would include array, and there you go. There's your array of bulls all stored contiguously and not in like a separate heap allocation. The one advantage the vector might have, depending on, I don't actually know if it's gonna be an advantage with like the way that the data is actually used, but vector has a specialization for bull, which basically makes it a bit field, meaning that instead of all of these booleans being 1 byte each, they're basically 1 bit each. They're packed into like an 8-bit data type, and then you can just use some bitwise operators to actually get the right value, which is really good if you're looking for like space efficiency and everything. But because we have to go through this level and process it, I guess probably every frame to actually draw it, if this is the main data structure, I don't know if just having a simple 1 byte data type that's effectively a bool would actually be faster to go through than having to unpack packed bits into 1 byte, you know? So that's actually an interesting question that I don't know the answer to. But anyway, whether or not you want to do this or actually an external file, I think both are totally viable. But a vector of vectors, multi-dimensional arrays, just don't do it. Multi-dimensional arrays. Not even once. This is literally a vector of vectors. So basically what it is 12 different vectors, 12 separate vectors instead of a single contiguous buffer of memory. And that, of course, is what we're trying to fix here. Hussein here said that personally, I would make use of the state design pattern to remove the state management from the main class, which is really good advice. And that, I think, is basically what has happened over here with all of this game state class introductions. So let's have a look and see what's going on here. So we now have this game state class. Again, I think header files they're not actually included. They're external dependencies. I don't know why. You need to make sure that you include the header files in the actual project. That would be really nice, thanks. So we have game state as like a base class, and then we have a bunch of pure virtual functions on it, and we actually store a game reference over here. Okay. And then we have a bunch of subclasses, and all these subclasses, of course, derive from this main game state class. So we have game state menu, play, win, lose. Okay. And they're all kind of within here. And then all of them implement the functions that they are interested in. So for example, all of them render basically, and they'll do so by calling all of these functions, which, I mean, to be honest, kind of look identical. I think game state win and game state lose are basically the same. And you can see by just looking at the code that it's super generic, meaning that what are we doing? We're getting the game UI, we're drawing a background, we're doing this render on play thing, which just renders the board, I guess. Every state probably needs that except for the main menu, which does something else. That does UI draw menu. Process input is going to do different things as well, depending on exactly what state we're in. So this is good. I mean, you know, it's probably not exactly how I would set it up, but it's definitely an improvement, because what it means is that inside the main class, instead of having a switch statement, we should just, I mean, this is inside. Oh, okay, so what's happened is I guess stuff has moved into this game class now. So we have our main game loop here. Oh, check this out. Begin drawing and clear background is now outside of each individual main kind of while loop per state like we used to have, which is great. And then we'll call render over here. It will probably just call current state render. So whatever the current state happens to be over here, it'll call the render function on that. So if we're in the play state, it will call this, which will weirdly go back to render on play. But that's okay. I think the problem here mainly is the fact that the game class is just doing too much. It's both running the application the whole application because it's managing the actual state machine for the game, but then it's also doing individual gameplay specific things, such as deciding how to actually render the whole game during gameplay. This could definitely be cleaned up by actually having an application class that maybe handled the application's current state and then went into a game class in order to tell it to actually render. The other thing that this state machine is missing is some kind of transition between states. So it obviously works the way that it's set up. So you'll see, for example, in menu process input, if we click the start button, then it will change the current state to something else. But there's not a very like transparent way to actually see how the state machine is laid out. So what state leads to what other state? We don't know that. We have to dig through the actual code to figure out, okay, there's actually a function here that will basically take control of the main application and redirect its current state instead of just reporting back that a state change has been requested. And that's definitely something you would want in a more robust system, because I guess the problem is that you don't really necessarily want your state machine to actually take control of your main application and tell it to immediately change the state like mid-frame potentially. I mean, this happens during process input, which if we have a look at main, that happens like over here. So you are kind of mid-frame. I mean, it's really the start of the frame, so it's probably not too bad. It's probably not going to cause too many issues, but I would just feel safer with a design that actually requests a state change from the game, and then it's actually up to the game class to do that change instead of for the state to access the game and directly change its state like immediately. But again, those are kind of subjective design decisions. Obviously, the suggestions that I've made would probably make this a more robust and transparent system overall, but it's really, really great to see this compared to what we had before, because guys, if you didn't watch the last video, you should give it a watch and see what we had before, because it's crazy compared to this. This is much, much better. Pete the Paper Boat also agreed that vector of bull was not the best decision. I don't quite follow this whole OOP interface design for food. It seems like it could just be a fat struct with an enum for the different food types with a switch on each unique behavior. So this is also something that happens very often. People will go a little bit overboard with how they lay out very, very simple gameplay logic elements, such as food. So we have an interface called object, which contains, oh look, weak pointers. So you do know about them. So you use them for other things as well. This is really good. I was not expecting to see this. This is good. So in this case, every game object actually has a weak pointer to the context in which it resides, which is pretty typical. But having a weak pointer means that it's not holding a strong reference to that object. So it's not able to keep the board alive. It's not able to keep it from dying, but it does have a reference to it if it is valid in order to use it, which is great. So then we have the food, as I mentioned, and we have the food type here as well. And then we have specific implementations of food, such as the apple, frog. Apple has food on the end, frog doesn't have food on the end. Mouse also. And then we have like these special actions, I guess, that they do. So the question here is, do we need such a complex system for the actual food? Meaning, do we need to have such a deep hierarchy? Do we need to have individual classes for absolutely everything? I would say that if every object here does something different, which it seems like it does. So for example, the frog actually has its own logic for what it does. It's got its own like movement implementation. I'm guessing the rendering is probably the same, but you can see that it doesn't even override rendering, right? So we just have move and do something is overridden. So ultimately, I think the way this is set up is probably fine. Like, yes, you could obviously just have a class called food and then have this enum type inside it, and then just have either a switch statement or some kind of dispatcher that dispatches the logic to an appropriate branch or an appropriate function. But this is doing the same thing. This is doing the same thing. It's just that it's organized in a bit more of like an OOP kind of inheritance way, but ultimately these are all individual objects with their own individual logic. So whether or not you use inheritance or composition for this, you're kind of achieving the same thing of just, I have some unique behavior that I would like to give an object of this particular type. And obviously this will scale much better than having them all in one object and then dispatching them to like certain behavior functions. The one questionable feature of this is probably whether or not you need this intermediate iFood interface. It's not really an interface, I think, because it's actually implementing lots of different functions. But I guess if you wanted something, if you wanted all food to, have to return like the amount of points they give you and whatever else, then maybe, but I feel like maybe this is adding a little bit of complexity and a little bit of a deeper hierarchy where it's just not necessary. So you could also just make mouse be, you know, an object, for example, and then give it some behavior. But that's just me trying to simplify things a little bit. I think that ultimately this is fine. All right, so overall, some nice improvements. Again, really happy to see the state machine. That was probably like the biggest problem that I had with the code. Well, the dual while loops were really weird as well, but this seems to have fixed that as well, which is great. Thank you to everyone who participated in the discussion on the code review channel on my Discord server. All of your suggestions were really good. It's also a great place to discuss some of the things that I may have said or get some clarifications if you don't quite get what I meant, as well as give some suggestions of your own, of course. So keep an eye on that channel. I've got quite a few juicy projects coming up next, but if you guys want to send in your code for me to review, then send it to chernoreview@gmail.com. That email address and some instructions will be in the description below. Thank you guys for watching. I'll see you next time. Goodbye.